So, hello from me. I'm George. I work as a software engineer at Prodyna. And today we are going to talk about dev containers. And first of all, let's see some statistics. So 75% jump through different projects daily. That means that there are many different stacks, technologies that as developers we must handle. The same percentage happens also in the people with the stacks. For example, one project is in Go, one is in Java. So there is a differentiation there, and we must constantly switch between those environments and technologies. 13% is an employee turnover rate in Europe. That means that employee turnover rate means that developers that come and go, leave the company and are being replaced. That's a big number. And 45% don't have a fully functional dev environment. They are doing workarounds in order to fulfill their daily routine, or they don't test at all, for example. And usually, every 3.5 years, the equipment of us changes. And we can extract the following problem with those statistics, that somehow we must have a very stable, easy to adopt, and secure development environment. That's very crucial because it's very expensive, and it will increase. If we don't do it, we won't increase our productivity. Fortunately, recent years, there's a technology that is called development containers or dev containers. Actually, it's an open specification that enriches containers with development-specific content settings. To be more descriptive, there's a Docker container that contains everything that we want in order to work in our development environment. And here is the official URL that you can read. So our agenda is going to be a really quick session. The level is for all beginners, but of course there are some people that already use that. We are going to see some basic features, nothing revolutionary, and some lessons learned from my experience. And of course, I will try to motivate you and maybe promote such a solution at your company if it doesn't exist. If you want more specific things, I can provide with some tools to learn a lot with. So, first of all, we have our local setup, a VS Code, for example, or IntelliJ. In my experience, VS Code works better. IntelliJ is not very stable at the moment with that technology. And we have a Docker container that has all these things. It has a file system, terminal processes, all the environment that we want, tools, and of course, ID-specific things like workspace extensions, maybe a theme or a tool that we can use in VS Code that exists in a Docker container. That's a very big picture of how it works. And the ID, VS Code, or IntelliJ connects to that Docker container. In order to easily start, first of all, there's only one prerequisite for local development. You must somehow have Docker installed. In different OSs, there are different approaches to that, but Docker Desktop applies to Apple and Microsoft. You can have VS Code or IntelliJ. There are some people that are working with GitHub code spaces. That's another approach, but you can work with that too. And if you open your VS Code and install the relevant plugin, you can type above, try a dev container, choose a stack that you are mostly familiar with. I chose Java, for example. And you will come up with a setup like this. First of all, you can see here in the left down corner that you are already in a container. It says dev container. Secondly, you could see here in the plugin section, in the second arrow, that some extensions are already being installed And those are the extensions that were installed not locally, but inside the container, and we can see those two. The local ones above are the ones that are already existing in VS Code in our setup. And we can also see in the terminal, arrow 3, that that specific space exists in a Docker container. You can see, for example, that has an OpenJDK 21 installed. If you go to the URL that I have showed you before, there are two main things there that you should know. First of all, there's a concept that's called features. You can go there and download a feature that you want. For example, I have chosen to install Java and SDK man inside the container that I chose. And there's another concept that it's called templates. And here you can see some specific images that contain Java with a database or Java with other tools like Java functions. And you can choose also what you want. Now, what's the difference? First of all, features provide a way to customize dev containers beyond the basic templates. And they allow you to add specific tool extensions or configuration. For example, Go with a PostgreSQL or Java via SDK man. And templates serve as a starting point for creating consistent development environment using dev containers. For example, there are tools like integration with Azure pipelines or a specific LaTeX configuration environment. Okay. Before we see that, there are 3 ways that you can create and configure a dev container. I can show you. Just a minute. Okay, by shutting everything down, everything works. So, if we want, we must create, first of all, a dev container folder. That's only a configuration folder. And the first and the easiest way is to have a dev container JSON. Inside that JSON, the first thing that we must do is to define a pre-built image. In our case, I have chosen an image that already contains JDK 21. Here there's a section that configures the feature that calls feature Java 1. That are some specific things, and we have seen before regarding SDK. For example, I have chosen Maven over Gradle. I don't know how many of you agree. And there's another section, customization section, and that is IDE-specific thing. I have chosen to install an extension that's called spell checker. And if I go here, I can see, although I have chosen to install that, there are 12 extensions installed in our Docker container. That because all the pre-built image, that one, already has 11. So I only extended the extensions. Here we have a section that we can do a port forward because, for example, if an application runs in 8080, that runs inside the Docker container, so we must expose it in the outside world. Currently, that's not the case. And we have some hooks, like post-create commands, that we can do scripts there, reference to external files, or we can directly write some commands. The second way is a combination of that dev container JSON and a Docker file. We can have such an extension, for example, such a configuration. You can see extensions, specific settings, or container environment variables that exist. And the thing that I want to show you here is that you can refer to an external file. You just pass the name of the file. Currently, it's the Docker file. And here I have chosen Ubuntu-based image, and I have installed some utils with that. So I have that configuration that refers to that image. And there's also a third way. You can have, again, a dev container JSON with similar configurations, and you can refer to a Docker Compose file. I specify that file, and you can see from the Docker Compose, I want to connect to that service, dev container, and that is exactly the name I want to connect to. And that's a multi-layer Docker Compose file. And I have chosen the image here, a base image here. But I can also refer to another Docker file. If I comment this out and comment those things in, I have a combination of a dev container JSON, Docker file, and Docker Compose YAML. So you are really, really flexible. OK, let me continue with the PowerPoint. OK, so some lessons learned. In my experience, in order to choose a base image, you don't think to overthink it. It's better to choose a big image, like a big Linux distro, because if you tune it to a specific language, you are going to have issues later on because you want more and more things. So don't be very specific about it. Just choose a big one. Don't improvise. It's easily to make something really complicated with these three variations. And if you need one single feature, it's better to use an existing image that contains that feature instead of improvising. Always using the mixture of the three ways that I have shown you is a good choice because it's a very scalable choice. One negative thing is that they consume a fair amount of resources locally, of course, but most of the times we don't care so much. And lastly, there are not VMs. So although you can choose as a base image some Windows images, and there are some tricky parts there, some of them may need licensing or not. But in general, it's not a good idea to use it as a VM, for example, to open a Google Chrome browser in such a container. That was pretty much. Thanks a lot. If you have any questions, thanks. I didn't expect that.
Is that open? Okay. Thanks for starters for the presentation, George. One question, when you said the base generic image, can it be truly generic or do we have to customize it to be like the base images that Microsoft offers for dev containers? Does it have any requirements?
I usually prefer an existing pre-built image specific to dev containers than have something built in my own, like with a Docker file.
I see.
But that depends on the case, I would say. But if something exists specifically for dev containers, I would opt for that because it already contains some extensions or some plugins.
I guess, is that open source? So
yes,
can we
yes,
see the base
source.
dev container images ourselves?
Most of it is open source, and I think it's maintained by Microsoft, but I may be wrong there.
Okay. Thanks. Thanks a lot.
Welcome. Thanks. If you want to follow me or ask me anything, feel free. Thanks a lot.